Hello and welcome to Chapter 5 in Computers and Healthcare. We are talking about system implementation. We're going to slide through that learning objective slide and we're going to start on page 69 in the text. So in Chapter 4 we talked about the system development life cycle and we talked about the first two stages, and in this chapter we're going to talk about the last two stages, implementations and maintenance and evaluation. So, system implementation is the process of preparing and launching the information system that has been selected for use. The system selection process continues until the information system is in use and has been evaluated as to whether or not it meets the objectives established at the beginning of the process. And so there are 13 steps we're going to cover in this chapter as a part of the implementation process. And so we're going to start with the first one over on page 60 or on page 70, and this is site and space preparation. So that's number 1. Site preparation requires making any needed changes to the physical location where the computer, workstations, printer, or other hardware will be installed. The needs of the site preparation vary widely, from construction of a new building to renovation of an old one, to use of existing structures and upgrades to the infrastructure. Modifications needed may require the installation of special air conditioning or floors designed to run cables under it, added security measures, or more electrical outlets, to name a few. However, site preparation may be as simple as moving existing hardware around to make room for the new. Failure to properly prepare the site and infrastructure will result in delays in the installation of hardware and software, which will in turn delay the entire implementation plan of the system. For example, a healthcare facility attempted to plug in a hardware and did not have an available electrical outlet. Alright, number 2 is user preparation. User preparation involves providing the users with enough information about the information system being implemented so that they are prepared both psychologically and through training to use it. This part of the change management process is discussed in Chapter 4 and continues throughout the project. It is important for information system users to be notified and updated throughout the system selection and implementation process. The users need to know that the information system is being implemented and should have an accurate understanding of what to expect from the information system and what is expected from them. Alright, our third one is installing hardware and software over on page 71. Once the hardware arrives, it will need to be set up and installed in the data center. Computers will also need to be installed in the nursing units, training rooms, and other locations according to the project plan. The printers, network, scanners, and other hardware will also need to be installed. The software will then need to be loaded onto the file server, mainframe, or other computer in the data center. Some applications require software to be used on an individual user's computer. If this is the case, the software will have to be installed on all authorized computers prior to implementation, especially for development and testing. Any failures in the site preparation will be identified at this stage. Number 4, programming and customization. Programming may or may not be required depending on the type of information system, complexity of the information system, and whether the healthcare facility is purchasing an information system or programming one themselves. If the information system interfaces with another information system to share information, such as patient demographics or other information, the interfaces will have to be programmed. If the healthcare facility is converting data from one information system, computer programming will have to be done to perform data conversion. Data conversion is the process whereby data are copied from the existing information system, manipulated into the format required by the new information system, and entered into the new information system. Although customization may better prepare the information system to meet the needs of the healthcare facility, there are reasons why the healthcare facility should not customize the software beyond what is already built into the information system by the vendor. First reason is if the healthcare facility makes changes to the software and then they have trouble with the information system, the vendor can blame the modifications. The vendor may then refuse to work on the system. Second, the vendor may not give the healthcare facility a service agreement. And lastly, Every time that the healthcare facility receives a software update from the information services vendor, the IS staff will have to check the modifications to see if they were affected by the new update. Because the healthcare facility may receive several updates a year, this could be an onerous task. All right, number 5, user configurations and settings. Most computer software purchased by healthcare facility generally provides some flexibility in the implementation of the information system. This flexibility is allowed through the setting configuration. Setting configuration is the entry of the desired behaviors of the information system into tables or setting fields. For example, if the information system will keep track of the patient type, the hospital determines if patients will be classified as inpatient, outpatient, emergency department, testing, outpatient surgery, and another patient type. The healthcare facility may even be able to determine that I means inpatient. All right, over to page 72, moving on to number 6, which is screen design. The information system may allow the healthcare facility to make changes to the computer screen so that it works the best for the healthcare facility. Screen design means developing screens of an information system to meet the needs of the user and promote job efficiency. To accomplish this goal, team members involved in this process must be aware of the needs of the user and the work they perform. Reasons why the healthcare facility may want to change the computer screens include the following. No single screen contains data needed to make data entry or viewing efficient. The vendor screens do not have data elements in a logical order for the workflow of the users. The existing screens are too cluttered for the user's preference, or changing the screen will improve the process workflow. The screen design may include designing computer views for various types of users. This flexibility would allow nurses to see new orders, care plans, and other information first. The cardiologist and neurologist would have first access to cardiac and neurologic tests, respectively. Graphical User Interface, or GUI, also called GUI, is a term used to describe the interaction of users and the computer whereby the user clicks on icons, menus, and other tools to assist in the use of the information system. Frequently, these icons are shown on a toolbar, and icons are provided shortcuts to functionality within the system, along with buttons and menus, allowing the user to command the software to perform specific tasks. And so we have different rules for our screen design that we didn't cover, so be sure to read that on page 72. And now we're moving on to number 7, the re-engineering process, the bottom of 73. Re-engineering is evaluating the way the healthcare facility does business in order to improve efficiency. Re-engineering is a task that is frequently overlooked in the effort to implement the information system. Every task and preconceived notion must be challenged. The question why should be asked over and over. Everything is subject to evaluation and change without exemption. This is challenging to employees who are comfortable with the status quo. Some of the tasks performed by the employees have been performed for years. The reason behind the task may be outdated, but the task continues because the employee is afraid to stop. The implementation of a new information system is a perfect time to critique the task performed to try and improve efficiency, cost, and effectiveness. And number 8, over on page 74, is policy and procedure development and documentation. So after the re-engineering is completed, the policy and procedure manual must be updated to reflect the new way of doing business. Policies and procedures should blend together the manual processes and decision-making processes. Management and maintenance of the system itself must also be clearly outlined. These policies frequently cover backups, downtime policies for routine maintenance, upgrades, testing of upgrades, and disaster planning. That brings us on to testing. All components of an information system will need testing before they go live. Testing helps the implementation team identify any problems with the system so that they can be corrected. This is a cyclical process, so the team will test the information system, identify problems, fix problems, and test the system again. The test cycle will continue until all problems have been resolved. Testing requires careful and detailed planning to ensure that the complete and accurate testing is carried out in a timely manner. And over on 75, we have our different types of testing. There are 9 total covered in this work. We have interface testing, which ensures that the interfaces function properly. We have integration testing, which ensures that all hardware, including computers, printers, and scanners, work together as they should. Then we have application testing. This ensures that every function of the new information system works. It also ensures that the information system meets the functional requirements and other required specifications in the request for proposal or contract. Then we have documentation testing. During the implementation process, a number of documents, including user guides, policies and procedures, and training materials are created. These documents should be followed during the testing process to ensure that the instructions in the document are accurate. Then we have conversion testing. This ensures that the project team is able to transfer data from the old information system to the new information system. And then you have training testing. The project team should train a group to see how well the training materials, agenda, format of training, time allotted for training, and other attributes work. Changes are made to the training process as needed before the real training begins. Then we have volume testing. Volume of the testing performed on the application is done with a handful of people sitting in an information system trying to identify problems. The information system may work fine with a small group of people, but most information systems are used by large groups of people simultaneously. To test the information system in a real environment as possible, volume testing should be performed. Volume testing gets as many people to use the information system at one time as possible. Then we have parallel testing. Running parallel tests is used for both testing and facilitating the transition of data and business processes. Unlike most other testing, parallel testing occurs when the new information system is operational. This is not a required test, but it can be a valuable one. In parallel testing, the healthcare facility runs the old and the new information system simultaneously and compares the reports and data from the two systems to validate both performance and synchronization. And then over on 76, we have our last testing, which is our acceptance testing. Like parallel testing, acceptance testing occurs after go live. It is a time to verify that the information system is working as expected in a live environment. All right, so dropping down to training, which is number 10 in our steps of system implementation. Training is crucial to the success of the implementation process. There needs to be a well-designed training plan that addresses the timing and methods used to train the user. The plan must be properly executed or negative repercussions can occur. Users may feel like they're reverting back to being a novice employee after being an expert in their position. Job security may be another concern. Individuals who are most concerned with the new information systems are often those who have little experience with computers. Communicating with employees and keeping them informed of changes, impact, and expectations of their position will help prepare them for training. And the learning curve is different with each employee. Instructors and trainers should have a basic understanding of adult learning principles and practice them in development and implementation of training. And some key adult learning principles are: first, adults like to be responsible for their own decisions. They resent not having control, so the instructor should let the learner have a say in the program. 2, adults are experienced. Adult learners come to the training session with a lot of experience and knowledge upon which they can draw. But not all adults have the same knowledge and experience. The instructors and students can learn from each other. Number 3, adults need to know why. Instructors should get into the habit of telling the adults why they need to do something or why they need to learn what they're being taught. 4, adults need to see relevance. They do not want to waste their time. They want to learn what they need to know for the immediate future. 5, the adults need to be ready to learn. Training sessions may be mandatory, and the learners may show up physically to the session, but they cannot be forced to learn. And last, the learner has to be motivated to learn. Some healthcare facilities have motivated learners by making them take a competency test at the end of the training session. This test makes the learner use skill they learned in the class. Learners are motivated because the healthcare facility sometimes ties employment to successfully completing this test. All right, so be sure to read the sections on planning for training and conducting the training, evaluating training. So just be sure to read all of that section. We're going to skip through that, and we're going to go on down to conversion at the bottom of page 79, which is step 11 in our implementation plan. So with most new information systems, a healthcare facility is converting from one information system to another, even if the first system is paper. The healthcare facility cannot ignore the historical data, but rather must bring some, if not all of it, to the new information system. In a paper system, the historical data must be captured through abstracting, scanning, or other data entry methods. In an information system implementation, conversion is transferring data from one information system to another while simultaneously making any necessary changes in format or content. A conversion is more difficult than it sounds because systems frequently store data very differently, or the healthcare facility may be making changes to how it wants data to be collected. For example, the health record number may be 10 digits in one information system and 12 in the other. Or Medicare may be entered as M in one system and MCR in another. During conversion planning, the project team has to determine how much data are being converted and what data fields will need to be converted from one format to another. All right, dropping down to step 12 in system implementation, which is go live. So go live was briefly discussed in chapter 4, and it's the official time and date that the healthcare facility begins using the new information system. The go live is generally scheduled for a time when the healthcare facility is the least busy. For example, a hospital will generally go live during the night shift because there's far less activity during that time. And so we've got different go live models here. We have a phased approach. In this method, the implementation starts with one module of the information system, and then gradually other modules are added. A module is a subset of an information system, such as a pharmacy orders. In a computerized provider order entry system, all units, departments, and other entities utilize the system, but they only use it one module at a time. Our next method is the pilot method. This approach is when only one nursing unit, department, or other entity starts using the new information system at a time. Once consistently successful, the next group is implemented. So our example is 3 West Nursing Unit starts ordering everything using the new information system, but nobody else uses the system. And then the next unit scheduled might be 3 East. And then our last method is the Big Bang method. It's also called the cutover method, and it is the riskiest. With this method, the healthcare facility stops using the old information system and starts using the new system. It is the riskiest because the healthcare facility may not have the old system as a backup, and the new information system is being used all over the hospital. And then we have 2 different types of turnover strategies. We have parallel processing and straight turnover. Parallel processing is similar to parallel testing. Although parallel startup works well, it is labor intensive and therefore expensive. Because the old information system is still in place and current, this approach provides a safety net and has the least amount of risk involved. Straight turnover, the former system and processes cease with the implementation of the new information system. There is a risk here if the new information system has to be aborted. However, it is most cost-effective and reduces the workload significantly because there's no duplication of efforts. And during your go live, you're going to have initial support, and then you're going to have ongoing support. So in the initial support phase, there should be a team member of the project team in every unit or department when the information system goes live. These project team members should be highly visible to one another. For example, they could wear matching shirts. Project team members are needed to answer questions and generally ensure that the information system startup runs as smoothly as possible. Trainers play an important role not only in the training, but also during go live, which means they are a key part of the implementation presence throughout the healthcare facility. And initially, while someone must be available 24 hours a day, 7 days a week, the length of time is going to be determined based on the magnitude of the information system and how well it's going, the implementation. Generally, the intensive support is only for a few days. There should be a help desk that users can call when help is needed. The amount of coverage will eventually be reduced to the regular help desk support. The project team must be prepared to go back to the old information system if the new one does not work. And then last step, system evaluation. After the new information system is implemented and functioning properly, the project team will need to evaluate how well the implementation went. System evaluation is how the healthcare facility determines whether or not the information system functions as expected. The project team needs to learn what did and did not work during the implementation process and determine how they can improve the next implementation. For example, the team may not have started system testing early enough, or maybe there were expenses that were not budgeted for. The project team will also want to know if the healthcare facility met the needs or met the goals that were established for the project and if the project came in on budget. This evaluation allows the project team to learn from mistakes and from experience. After a predetermined time period, the project team will need to determine if the healthcare facility has realized all expected benefits and all of the goals that were established during the planning and analysis phase. For example, did the healthcare facility save the money that was expected, or did it reduce the turnaround time of obtaining test results? Dropping down to the very last paragraph. Also in this stage, there will come a time when the information system is no longer meeting the needs of the healthcare facility. The vendor may stop supporting it, the healthcare facility may need more functionality, or users than the current system will accommodate, and other needs may arise. When this obsolescence occurs, the process begins again. So again, cover the highlights of the chapter. Be sure to read the entire chapter yourself. And happy reading, happy studying.